Good morning. Here I am. What I'm going to be doing this stream is solving multi-step equations to begin with. So, great. I can write on here. So, the first equation says 4n take 2n equals 4. Clean up the left-hand side. So do 4n take 2n to get 2n. Then divide both sides by 2 to get n equals 2. Finally, do the check step where you pick up the final answer, you substitute it into the original equation, and you make sure that it works. So I'm going to replace n here with 2 and n there with 2 as well. And just so you can see what I'm doing, I'm going to put 2 right there where n is, and 2 right there where n is. And of course, we know that when we see 4n, that really means 4 times n. And what their claim is that that should equal 4. Now, does it? Well, 4 times 2 is 8, and 2 times 2 is 4. And indeed, 8 take away 4 is 4. So that works. In an equation, the left-hand side is sometimes called LHS. And then you have the equals sign. And then you have the right-hand side, sometimes called RHS. Okay. Problem 2. Negative 12 equals 2 add 5v add 2v. We have to clean up the right-hand side to collect the like terms. So I write negative 12 equals 5v and 2v are like terms. They match. Think of 5 bananas, add 2 bananas. Well, that's 7 bananas. So I write negative 12 equals 2 add 7v. Just like that. And my aim is to get v by itself. So I take away 2 from both sides. Taking away 2 from negative 12 gives me negative 4 on the left-hand side. And taking away 2 from the right-hand side means that this guy disappears. Okay, because I've taken away 2. So I'm just left with 7v on the right-hand side. And now I'll divide both sides by 7. Negative 14 divided by 7 is negative 2. And 7v divided by 7 is v. So v equals negative 2. We would usually write it this way around, but it really doesn't matter at that stage, at the last stage. So that's my claim, v equals negative 2. But of course, I have to check. I have to check and make sure that what I'm saying is true. So that means picking up negative 2 and putting it here where v is and here where v is. So I write out the equation. I write the original equation. I write negative 12 equals 2, add 5. And then I'm going to put a pair of brackets there. And then add 2, and then a pair of brackets there. And I stick in negative 2 in that spot right there, and that spot right there. Okay. Then I write negative 12 equals 2. Now, 5, open brackets, negative 2, close brackets. This bit right here means 5 multiplied by negative 2, which is negative 10. 5 multiplied by -2 is -10. And when you add on -10, that's the same as taking away 10. Also, over here, 2 times -2, well, that's -4. And if you add on -4, that's the same as taking away 4. So now this becomes -12 equals whatever that is. 2 take 10 is minus. Wait, did I do this wrong? No, sorry. 2 take 10 is -8. And -8 minus 4 is -12. So that checks out. Sometimes you might see a little tiny question mark at each step of the checking stage above the equals sign. This is a legitimate symbol, an equals sign with a little question mark above it. And it just means like, I don't know yet if the left-hand side is actually equal to the right-hand side. I don't know yet. It's not clear enough yet. And when you get to the very end, you need to make your judgment call, and clearly it actually is in this case. Okay, speeding up a little bit now. 3 equals, what's x take 5x? Well, that would be -4x. So I write -4x add 3. And then I take away 3 from both sides. So I'm going to have 0 equals -4x. And if I have -4 of something and I have 0 as the result, well, then I must have -4 of 0. That's the only way that can happen. Now, the check step. If you pick up 0 and you put it back in the original, you can clearly see that this term basically disappears, and so does this one, and then we end up with a statement that 3 is equal to 3, which is true, so it's true. Over here, x add 3 take 3 equals -6, plus 3 take 3, that reduces to nothing, so x equals -6, and we're done. This problem here, we straight away go to the right-hand side. 3 take 2k takes 3 take 2k take 3k is 3 take 5k. Then we take away 3 from both sides, the left-hand side and the right-hand side. Taking away 3 from -12, we get -15. And on the right side, we have -5k. And then divide both sides by -5. Or just think to yourself, what do I have to multiply -5 by to get -15? And the answer is obviously 3. We do the check stage. We pick up 3 and we put it in there. So 3 take 6 take 9. 3 take 6 is -3. -3 take 9 is -12. So it's true. Over here, left-hand side, -3 add 2r is -r. So -1 equals -r. So r equals 1. Once you get good enough at these, I'm not encouraging you to skip past the checking stage. Of course not. If you're not confident, don't skip past the checking stage. But, speed is something valued as you move on. So you don't always have to check. Not always. But here, it is indeed true. Or you can just check in your mind very quickly. And of course, apply like common sense. Like if your answer is 1,000,000, a huge red flag should go off in your mind. Now, in problem 7, it's more interesting. we have options. Here's path 1. Path 1 is I'm going to divide both sides by -3. So on the left, I'll have 6 divided by -3, which is -2. And on the right, I'll just have x plus 2. Right? Think of the right-hand side as if it's like -3 in a bubble multiplied by x add 2 in a bubble, right? So two things multiplied together. So I've divided the right-hand side by -3, so this bubble just disappears, it pops. So I'm going to have x add 2 on the right. And then I take away 2 from both sides, and I have x equals -4. That was path 1. Path 1. What's the other path then? Well, the other path is to expand, which is a fancy algebra word for multiply, and it really just means getting rid of the brackets. So how do I expand in this case? Well, I first multiply -3 by x. It applies to the right-hand side. I first multiply -3 by x to get -3x, then -3 by 2 to get -6. And then we just carry on like normal. So add 6 to both sides. So 12 equals -3x. Divide both sides by -3. And 12 divided by -3 is -4. And the two paths agree with each other, which is great. Two separate methods agreeing with each other. Okay. You can clearly see that path 1 is a little bit faster, but it does rely upon you being able to do division correctly, which some people consider to be harder than all the other operations. Okay, we're going to do path 1 for this question over here. We're going to divide both sides by -3. So 4r take 8 equals, what's -36 divided by -3? That would be 12. Then add 8 to both sides, so 4r equals 20. Then divide both sides by 4, so r equals 5. Okay, here, both sides over 4. 4 on the left. -x take 3 on the right. You see how that's faster when I say it like that? We need to speed up, get at that sort of speed. Add 3 to both sides. 7 equals -x. Negate both sides. X equals -7, and we're done. Just there like that. Problem 10 here. Both sides over 3. 25 equals -6n, take 5. Both sides add 5. 30 equals -6n. Both sides over -6, n equals -5, and we're done. Here, both sides over -3. No. How would that help me? I would have 14 take r divided by -3. That's not much help. In this case, it's actually better to do path 2, where we expand on the left and see where it takes us. Okay, so expanding on the left-hand side. That means -3 times 1, which is -3, plus -3 times 6r, which is -18r. And the right side remains untouched. Now, we want the r's to just appear on one side of the equation, and then all the rest, all the numbers on the other side. Okay, so right now, -18r is on the left and negative r is on the right. So we have a choice. We could add r to both sides. That's one way to do it. So let's just do it. So negative 18r, add r is negative 17r. So this gets updated to negative 17r. And the right side now just becomes 14. Then add 3 to both sides to get rid of this negative 3 over here. So we have negative 17r equals 17. And finally, do this little arrow thing here. Divide both sides by negative 17. So r is negative 1. Just like that. Okay. In this problem, similar story. Expand on the left-hand side. So 6 times 6v is 36v. 6 times 6 is 36. 36 take 5 equals 1. Add 6v. Just like that. Then clean up the left-hand side. 36v. Add 31 equals 1. Add 6v. And take 6v from both sides to have v only be on the left. So we'll have 30v there. And take 31 from both sides. What's 1 minus 31? Well, it's minus 30. So this tells us that v is negative 1. Fantastic. Problem 13. Expand the brackets. Gather up your k's. So this is 6k on the left, and we've got negative 3k on the right. So we're going to add it on. 6k add 3k is 9k. Add 12 to both sides. So 9k equals negative 27. So k is negative 3. You see what I mean about speeding up? Okay. Here in problem 14, expand. When I just say expand, it's expected that you know what that's pointing to, this bracket here on the right-hand side. What else could it possibly be? So negative 7 times negative 6, that's 42. And then negative 56n, and then add 3. They will say something like this. N's on one side. It's quite a common expression. It really just means get all your n terms on one side. The left-hand side or the right-hand side, doesn't matter which, but just get them on one side. So I'm just going to take away 5n from both sides. So what am I going to end up with on the right? Negative 61n. Then they may say constants on the other side. Constants on the other side. And that just means numbers on the other side of the n. So in this case, the left side. So we do 42 add 3 to get 45 on the right. And then we have to take that away from the left. So negative 16 take away 45. So negative 61. So n is 1. Simple. Here, clean up the left. What does that mean? Clean up the left? It just means collect like terms, and that means collecting all the p terms and collecting the constants together. So clean up the left. Okay, 9p. What's 9 take 11? Negative 2. Clean up, expand, and clean up the right. So we've got negative 4p there, negative 6p there, so negative 10p. Negative 8 there, positive 6 there, So -2 there. P's on one side. So really 19p. Constants on the other side, add 2 to both sides. So we're going to have 0. So p is actually just 0. Right, this one. If I'm feeling a sort of, that doesn't feel right, I must check. I must check. It's like spidey senses. Okay, so if p is 0, that's going to disappear. So will that and that. And so it just becomes 9 take 11, which is -2. Oh, so does that one. 9 take 11, which is -2 on the left. And then that's equal to -8 plus 6 on the right. And that indeed checks out. That's fine. Great. Okay. Expand and clean both sides. So straight away, I go to the n terms. 3 times a10 is 24n, 24n, take 10n, here is 14n, and we're done. 3 times 8 is 24, and then that's equal to what? -6n, add 24, and we're done. N's on one side, plus 6n to both sides, take 24 from both sides. Oh, wait. So that 20n equals 0, so n equals 0 in this case as well? I guess so, because that would mean 24 on the right and 24 on the left, so it checks out. So it's fine. Right, okay. Now, expand on the left. I'm going to take this one slow. 10 times x, 10x. 10 times 3, 30. But what do we do here? A minus sign in front of a brackets. What you do is you flip the sign of each individual term inside the brackets. So we have the first term being -9x and the second term being -4. And we're going to flip the sign of the first term and then the sign of the second term. So that becomes plus 9x. And that becomes plus 4. And great. And on the right side, I mean, you have to clean this up. That's just going to be x take 2. Next, on the left side, we're going to have 19x add 34 equals x take 2. And what's going to happen here is, well, 18x equals 36. So, oh, beg your pardon. That's completely wrong. 18x equals -36. So x equals -2. Great. Okay, left-hand side. 12 times 2k, 24k. 12 times 11. What am I doing? Can you see this? Look at this. What do you think I should do here? Divide both sides by 12. Divide both sides by 12. Why expand? Why, engage with the 12 times tables when the claim is that 2k at 11 is equal to 2k at 12. And we think about that. So I have this quantity, which I've added 11 to, and it's the same as that quantity which I've added 12 to. Does such a quantity exist? No, it does not. And we can prove it because we take away 2k from both sides, and then the claim is that 11 equals 12, which is false. So we can just say no solutions. That can happen. I mean, what if I just said x equals x add 1? Does any number satisfy this? No. No number satisfies that, so it has no solution. It's an equation with no solutions. All right, so here in problem 19, you know what you can do is you are authorized to multiply both sides of an equation by the same number, as long as it's not 0. So you can double both sides of an equation, totally legitimate. Triple both sides of an equation, also fine. And in fact, you can multiply both sides of an equation by -1. What do I mean by that? I mean, flip the sign of both sides of the equation. So this becomes +12, this becomes +9, and it's just a bit less of a headache, right? I mean, who wants to multiply by negatives? So we expand on the left, we get 12x, take 144, and expand on the right, we get 9 at 63x. Take 12x from both sides. So -144 equals 9. Add 51x. Then take 9 from both sides. So -153 equals 51x. Then divide both sides by 51. So x is equal to -3. Over here, problem 20. Expand on the left. So that becomes 10p plus 100. Great. And expand on the right. You write down your 4, and then you do -5 times 2p. Remember, this sign is included. -5 times 2p, which is -10p. Then -5 times 11, which is -55. Clean up the left. 10p at 89. Clean up the right. What's 4 take away 55? -51. So it becomes -51 minus 10p, just like that. Add 10p to both sides. Okay, so 20p on the left. And take away 89 from both sides. So -51 minus 89. Well, that's the same thing as 89 add 51 with a minus sign in front of it. So 89 add 51 is 140. So it becomes -140. And so dividing now both sides by 20. So we get that p is equal to -7. Great. Now, in the last problem, they say, explain 2 ways you could solve this equation 20 equals 5, open brackets, -3 plus x, close brackets. Well, we outlined that earlier with path 1 and path 2. Path 1 says expand on the right-hand side, the RHS. So 20 equals -15. That's 5 times -3 and plus 5x like that. Then add 15 to both sides. So 35 equals 5x. Divide both sides by 5. So 7 equals x. That's path 1. Path 2 is divide both sides by 5. So 20 divided by 5 is 4. And then that leaves us with -3 add x on the right. Add 3 to both sides now, and 7 equals x. And great, we're done. Okay, that lot has been handled, solving multi-step equations. And so next, we move on to work word problems. Work word problems. Okay. So what's this all about? Well, it's about word problems which we have to work through. I guess that's it. Solve each question, round your answer to the nearest hundredth. To the nearest hundredth. That's very important. A lot of people ignore this, the accuracy demands, and they go too far or not far enough. But we're going to get it, we're going to do it right. Okay, problem 1 says it takes Kali 8 minutes to sweep a porch. Shauna can sweep the same porch in 11 minutes. If they work together, how long would it take them? I mean, this is sort of like assuming things, isn't it? About how sweeping a porch works. Right. I mean, did they even like mention that? Okay, so based on their assumptions about how a porch works and how sweeping a porch works, they say 4.63 minutes. 4.63 minutes. And nobody says 4.63 minutes in real life. So is that tremendously useful? Okay, and then we have 3.73 hours here. This is also not how people speak in real life. Well, anyway, okay, so what's going on here? Well, one way that you might be thinking about it is like Kylie handles one half of the porch and then Shauna handles the other half. So for Kylie, that would take 4 minutes on the left, and for Shauna, that would take 5.5 minutes on the right. So that's obviously wrong. So that would give us 5.5 minutes, because we would sort of take Shauna as the upper bound, because you're only as fast as like your weakest link in a way. So this isn't right. So where did they get this from? Takes Kylie 8 minutes to sweep a porch. Well, okay. Right, so let's say a porch is like 1 square meter. I mean, it's not, but let's just say that it is, just for simplicity's sake. Then Kali, who I'm going to do like in red, and then Shauna, who I'm going to do in blue. Like Kali's going to go at, I don't even know what the gender is, but okay, it's fine. Kali's going to go at their rate, which is they're going to cover this whole thing in 8 minutes. So imagine that they start up here and they go like this. And then Shauna is going to do this thing at their rate, which is in 11 minutes. So imagine they're going to start down here and they're going to go at their rate, which is like this. And then the question is, when do they sort of like cover the whole thing? I think I'm getting that right. Yeah. Okay. Might even be simpler to just imagine it as sort of like 1 meter there. And yeah, that's actually a simpler way to picture it, I think. I never considered this. Okay, so Carly's going at their rate, which is like 1 meter every 8 minutes. Per 8 minutes. And then Shauna is going at their rate, which is 1 meter, or like -1 meters, I guess, per 11 minutes, every 11 minutes. And then the question is, when do they crash? Because that's when the whole thing will be covered. And the final answer is 4.63 minutes. So if you're going at 1 meter every 8 minutes, what's your speed? What's the speed of Kali? 1 meter every 8 minutes. Well, how many 8 minutes are there in 1 hour? There are like 7.5 of them. So they're going at 7.5 meters per hour. I guess you could say that. This looks terribly confusing. It looks like miles per hour. Okay, and then what about Shauna? What's their speed? They're going at -1 meter every single 11 minutes. And how many 11 minutes are there in an hour? Well, there's 5 of them, and then 5 over 11. So like 5 and 5/11ths of a meter an hour, something like that. Okay, and then you add their speeds together. So 7.5. Because if you think about it, this is like the brakes on a car, and this is like the accelerating pedal on a car. Although you would never operate a car in this way. So 7.5, take 5 and 5/11ths, which is well, common denominator, please. So that's 10 over 22. That's 11 over 22. So like 2 and 1 over 22. That many meters per hour. What the hell is going on with this? No. This is totally wrong. Look at that. That's totally wrong. Completely wrong. I understand now. Sometimes this happens. Like it just clicks. And you're just like, how could I have not seen it? I can impute it to anything I like. Oh, it's the early morning. I haven't had my whatever yet. Sometimes it's just being human. Okay. So, the correct way to see it is you need to think about the gap in between them, which is like closing up. Okay. Kali is contributing this much to the closure of the gap. That's their speed. And then Shauna is contributing this much. So let's combine them because they're combining forces, right? So Goodness me. That's on that's on the permanent record now. I really don't care. So 7.5 plus 5 and 5/11 is 12. So this is 11 over 22, and that's 10 over 22. So 11 and 10 is 21 over 22. 12 and 21 over 22 meters per hour. Okay. How long does it take them to cover a single meter? Well, that would be 1 hour, which is 60 minutes, divided by 12 and 21 over 22. I'm going to have to use a calculator for that. I mean, you could get a rational number, but you're going to decimalize it eventually. So on the calculator, you type in 60, you divide it by, then you have the fraction button. So you do shift, and you press the fraction button, and then you will get a mixed number. 12, 21 on the top, 22 on the bottom, and we get the number that we're aiming for, which is 4.63 minutes. 4.63 minutes. Okay, so I understand it now. And once you understand it, try and think of a way to do it better, because this was a train wreck. But you gotta train wreck sometimes to improve. So, problem 2. It takes Heather 7 hours to pour a large concrete driveway. Alberto can pour the same driveway in 8 hours. How long would it take them if they work together? So it's like the same deal, but different numbers. So right, so over here, first we figured out the speed of Kali, and over here we figured out the speed of Shauna. The speed of Kali was 7.5 meters per hour, and we could have done that in per minutes. So how much of a porch per minute? Oh, of course, 0.125. That's what it is for them. Okay, so for Heather, how much of a concrete driveway per hour? 1/7. For Alberto, how much of a concrete driveway per hour? 1/8. So, combine forces now. How much of a concrete driveway per hour? Well, 1/7 plus 1/8, right? Common denominator, 56. So this much of a concrete driveway per hour. Then how many hours will it take them to fill up the entire driveway? One concrete driveway divided by their combined speed. That there is like combined speed. So that will be 56 over 15, which is 3 and 11/15. And that looks right to me. Now, do you remember the original requirement? It was to get it to the nearest hundredth. Anyway, you type in 3 and 11/15, and you do indeed get 3.73. Great. But I hear you ask, no one says it this way, so how would you usually say it? Okay, so 60 minutes in an hour. So this here would be 44 on top, 60 on the bottom, just timesing top and bottom by 4. So I would really say, in real life, 3 hours, 44 minutes. Okay, I think I get it now. So now to try problem 3 and see if I can get it right. Working alone, it takes Stephanie 7 hours to clean an attic. Right, so she cleans 1/7 of an attic. Attic with an E on the end. 1/7 of an attic per hour. That's Stephanie. What about Shayna? Shayna can clean the same attic in 12 hours. Oh, okay. So her speed is like 1/12 of an attic per hour. That's way clearer to me. Find how long it would take them if they worked together. Okay. Combining forces, making assumptions about how they work, like they somehow work at like the opposite side of an attic, as if that's really possible in real life, which it isn't. You really just get in each other's way. Okay. Combined speed is a 7th at a 12th, which is common denominator, please. That would be 84. 7 and 12 on, well, 12 and 7 on top. I should get it. It doesn't matter, but to me it does. Okay. 19 over 84. That's their combined speed. They clean 19/84ths of an attic per hour. So we do one attic divided by 84 over 19. Oh, goodness me. One attic divided by 19 over 84, which will end up being 84 over 19. And how many 19s go into 84? Well, let's see. 4 times 19 is 76. And then we have 8 remaining. So like 4 and 8/19. So to the nearest hundredth, they say, well, 19 goes into 100 about 5 times. So it's going to be like 4.4-ish. But you have to check. 4 and 8/19. Okay, so it says 4.421. To the nearest hundredth, that's 4.42. Let's check. Great. That works. Wonderful. All right. Problem 4. It takes Daryl 9 hours to mop a warehouse. So Daryl mops 1/9 of a warehouse per hour. That's his speed. Castell, I don't know if that's right, Castell can mop the same warehouse in 8 hours. So their speed is 1/8 of a warehouse per hour. What's their combined speed? 1/9 plus 1/8, which is 8 add 9 over 72, which is 17 over 72. This much of a warehouse per hour. 17/72ths. As if that's really how you say it. 17 out of 72 parts of a warehouse per hour. So how long will it take them if they worked together? It would be 1 divided by their combined speed. A whole warehouse divided by the speed at which they can clean a warehouse. And that gives you the amount of time it takes them to clean the warehouse. So 1 divided by 17 over 72, which is the same as 1 times 72 over 17. And 17 is when you times 17 by 4, you get 68. And then we have 4 left over. So it's like 4 and 4/17. And 4/17 is about a quarter. So I expect the final answer to be around about 4.25-ish. So on the calculator, 4/17. So this is what it does on my calculator. And then you press S to D and you get the final answer, which is 4.235, which to the nearest hundredth is 4.24. 4.24. 4.24 what? I hear you ask. You haven't given units. Okay, over here it I should have said 4.42 hours. Over here it's 4.42 hours. Over here I should say 4.24 hours. And once again, this is not how people really speak in real life. They don't say 0.24 of an hour. I don't think so anyway. They would say hours and minutes, but just please make sure that you don't say 4 hours, 24 minutes. That's just totally wrong. Right? 4.5 hours is 4 hours, 30 minutes, not 4 hours, 50 minutes, right? Just make sure you have that firmly in your mind that it's not that straightforward to convert it. Okay, problem 5. Working alone, Shanice can tar a roof in 12 hours. So straight away, I write Shanice. Their speed is 1/12 of a roof per hour. One day, her friend Catherine helped her, and it only took 5.14 hours. Interesting. How long would it take Catherine to do it alone? So Shanice's speed is 1/12 of a roof per hour. Catherine's speed is X of a roof per hour. We have no idea. We have no idea, right? Wait, we actually do have an idea. We actually do have an idea. Okay, so could Catherine's speed be 20 roofs in an hour? 20 roofs in an hour. Like she's Superwoman. Could it really be that? The answer is no. Because if Catherine were helping Shanice, Like, clearly, I mean, yeah, Shanice is going to slow her down, but by that much? No. So we have some idea, right? But anyway, point is that we don't actually know. So we're going to just say X for Catherine's speed. Now, what's the process we've been doing so far? Well, we combine their speeds together. That's what we've been doing so far. So, like, following the same process, that would be 1/12 add X. And that's equal to their combined speed. That's their combined speed. That's how much of a roof they clean per hour when they're working together. So what about okay, and what is X plus 1/12 as a fraction? What is X plus 1/12 as a fraction? Well, it would be 12x at 1/12. That's their combined speed. Good stuff. And then we end up doing 1 divided by that quantity. That's what we've done so far. 1 divided by that quantity. And that is apparently, in this case, equal to 5.14. So now it's just a game of solve for X. When you do 1 divided by something, you flip it. It's called the reciprocal. So 12 over 12x add 1 equals 5.14. Then to get x by itself, we're going to do 12 equals 5.14 and multiply 5.14 by that denominator there. So I put 12x add 1 right there. Then I expand out. So 5.14 times 12. Well, times it by 10 and you get 51.4. Times it by 2 and you get 10.28. So 61.68. That much. Okay. 12 take away 5.14. Well, that's like 7 take away 0.14, which is 6.86. Okay, and now divide both sides. This is a lot more working out than what I think it should be. I guess I'm doing it inefficiently. But that's how it goes, you know? You figure out how to get better while you're doing it. Okay, so the answer that we have is 0.111219, etc. Because it's 0.111, that's very close to 1/9. So I do wavy equal sign and I write 1/9. And why do I say that? Because it's well, it's like 0.111. That's to the nearest thousandth. So I'm pretty sure that Catherine cleans a roof in like 9 hours. Faster than Shanice. Okay, so like I'm going to say 1/9. But we're going to check. We have to check. Okay, so they say 8.99 hours. Okay, technically, right, let me do 1 divided by my answer. Right, okay. Technically, they're fine. 8.9, give me a break. 8.99 hours. All right, fine. You win. 8.99 hours. Right, so whatever, we're going to move on. Nicole can pick, what are these units, man? 40 bushels of apples in 15 hours. No, you know what? That's legitimate. I really do want to know what a bushel is. Is that a tree? Let's check. What is a bushel? A measure of capacity equal to 8 gallons used for corn, fruit, liquids, etc. You know what? I'm visual. So, is this a bushel right here? No, that's it on the first one. But you know what? There's not a human next to it. So, how's that for visualization? Look, it's about a bucket, okay? Let's just say that. I don't need to know exactly how much. So, Nicole can pick 40 bushels of apples in 15 hours. And Carlos can pick the same amount in 11 hours. How long would it take them if they worked together? You see this 40 here? This number 40 right here? That's a distraction. Imagine if 40 bushels was like a tree. So we would say Nicole can pick a tree of apples in 15 hours. Carlos can pick the same amount in 11 hours. And the question is the same. The 40 is not actually relevant right now. So Nicole's speed is, that much every 15 hours. So it takes them, so they can do 1/15 of that. 1/15 of 40 bushels per hour. So that's their speed. What's Carlos's speed? 1/11th. What's their combined speed? 1/15th add 1/11th. Okay, so that's 11 add 15 all over. What's 15 times 11? 165. So 26 over 165. Like that. And 1 divided by that quantity is the same thing as 1 times the reciprocal. And how many 26s fit into 165? Well, 5 times 26 is 130. 6 times 26 is 156. So it's like 6. And then we have 9 left over. And 9 over 26, well, that's nearly 9 over 27, which is like it's about a third, right? But we have to get it to the nearest hundredth. I'm not satisfied with my approximations. So we're going to type in a 6 and 9 over 26. And we get 6.346. 6.346 to the nearest hundredth. That is 6.35. Thank you very much. Let's see if we're correct. We did it. Wonderful. That's actually true. 6.35 what though? 6.35 hours. Must not forget my units. Problem 7 says, working together, Arjun and Maria can oil the lanes in a bowling alley in 4.24 hours. Had she done it alone, it would have taken Maria 8 hours. How long would it take Arjun to do it alone? Oh boy. Back to their usual tricks, huh? So, Arjun, Maria, combined. Okay. So, had she done it alone, Maria would have taken 8 hours. So, what's her speed? Her speed is 1/8 of a bowling alley per hour. Am I getting that right? Yes, that's right. That's her speed. Whose speed do we not know? That would be Arjun's. We'll say X. What's their combined speed? They can do a whole bowling alley in 4.24 hours. So it's like this. This is their combined speed. 1/4.24. Okay. So how to now figure out X? Well, isn't it just 1/8 plus X equals 1/4.24? Am I getting that right? Well, let's see. I mean, clearly here X is just 1/4.24. Take away 1/8. And for that on the calculator, 1/4.24, take away 1/8. We get 0. We get 47/424. Which approximately is 0.111 to the nearest thousandth. Now, how long would it take him to do it alone? Well, that's, this fraction will then go right there where X is. And how did we get 1/8 for Maria? Well, we took the amount of time that she took, and then we did the reciprocal of it, right? She took 8 hours to clean a whole bowling alley, and then we just did 1 divided by 8. So, this isn't, again, this is really close to like 1/9. So Arjun's real number is going to be like about 9. Okay, but we're just going to basically flip this. That's his speed. So 424. Can you believe it? I just wrote 242. 424 over 47. And we get 9.02 to the nearest hundredth. We go down here and we see that that is correct. Great. Problem 8. Working alone. Eduardo. I've always heard that in TV shows for someone called Edward and then they nickname him Eduardo. But, it might be a real name and I just haven't encountered it yet. So Eduardo can harvest a field in 14 hours. One day, his friend Amy helped him and it only took 7.47 hours. How long would it take Amy to do it alone? So this is pretty much copy paste of problem 7 it's a clone. So we just write Eduardo. Then we write Amy. Eduardo's speed harvests a field in 14 hours. So how long does it, what's his speed? Oh, 1/14 of a field per hour. What about Amy's speed? We don't know. So in this case, she is X. Combined. What's their combined speed? Like the 7.47 hours here, so it's 1 out of 7.47. And we know that 1/14 plus X equals 1 over 7.47. So please find out what X is for me. That would be 1 over 7.47. Take away 1 out of 14. 747. What, the plane? Okay. Goodness me. Look at that number. 653 over 10,458. No problem. As a decimal, it's this number here, 0.062. Okay, fine. So we just do the reciprocal like we've done. So I'm just going to type in answer and then raise it to the power of -1. That's the fancy way to get a reciprocal. So it says 16.02. 16.02 hours. Let's check if it's right. Oh, and it is. Very good. Okay. Great. We're not giving up yet. Working together, Mary and Trevon can inflate 20 balloons in 7.34 minutes. Had he done it alone, it would have taken Trevon 14.1 minutes. How long would it take Mary to do it alone? So we write Mary, Trevon, and using the language of the question, together, although I prefer combined. Oh, 14.1 minutes. That's the speed of Trevon. Oh, this 20 balloons thing here, this is again like another distraction, like the 40 bushels from earlier. So his speed is 14. He does it in 14.1 minutes. And you see up here, we for Eduardo, he could harvest a field in 14 hours. For Trevon, he can blow up those balloons in 14.1 minutes. In both cases, though, we just like do 1 divided by that number. So Trevon's speed is like 1 over 14.1. Sounds bizarre. It is. But you just continue. Mary, her speed, we don't know. Combined speed together, 1 out of 7.34. Like, that's how much of a what's the collective term for balloons? You know the movie Up? I want to say that thing. a cloud of balloons, whatever. Okay, there you go. That's their combined speed. So, like before, their combined speed is, excuse me, just for a sec. Okay. Yeah, I mean, it's pretty much just a clone. So 1 over 14.1 plus x equals that. So x equals 1 over 7.34, take 1 over 14.1. And we end up with some horrendous decimal, but that's totally fine. 1 over 7.34, take away 1 over 14.1. That is huge. 3380 over 51747. And when you flip it, and the fancy way to do that is to type in ANS, that's like answer, and raise it to the power of -1. You get 15.31. That's to the nearest hundredth. So Mary, that's her speed. That's Mary's speed. That's how many bags of balloons she can inflate per minute. So Mary would take 15.31 minutes to do it alone, I believe. We're going to check. Bingo, we got it. Okay. Problem 12. Shreya can weed a garden in 19.3 minutes. Is that right? So your speed is like one whole garden in 19.3 minutes. One day, her friend Elisa, helped her, and it only took 7.44 minutes. Okay, so Elisa's speed, we don't know. We say X. Together, they took 7.44 minutes. So their combined speed is one whole garden in 7.44 minutes. Great. How long would it take Elisa to do it alone? It's very much the same. X is just going to be 1 over 7.44. Take away 1 over 19.3. And that will be a massive fraction. So we just do 1 over 7.44 and take away 1 over 19.3. And we get this massive fraction. But you know what? Recently, I have very much warmed to rational numbers. One integer divided by another non-zero integer like this, even if they're huge. I think they're very cool. So that's their combined, that's Elisa's speed. Now, what is her time? How long would it take her? We do the reciprocal. And we get 12.11 minutes. That's to the nearest hundredth, which is about 12 minutes and 6 seconds. Great, that's correct. Okay, now keep in mind the practical, the real. Okay, so over here with Mary and Trayvon for inflating balloons. Okay, this is actually kind of okay because like you can divide up balloons and you can like take them separately, but you're gonna have that one balloon and it's like you can't combine forces with inflating a balloon. I'm sorry. Okay, a single balloon, I mean, right? So that's like the limit of the mathematics here. What about this? Weeding a garden. Okay, if the garden is arranged such that it's sort of like a field and it has these rows, you know, maybe you can do that. Maybe you can go around the perimeter, whatever. But if it's sort of like patchy, you don't know. Maybe combining forces doesn't help. But the most clear example where you can't just combine forces and just add things up in this way would be like in a kitchen. You know, yes, having another chef there is usually going to cause you to speed up cooking, the preparation time of a meal. But okay, is having 100 chefs there going to speed it up? No, it's gonna actually, you'll get in the way. So with all that said, problem 11. Huang, I believe, can wash a car in 10 minutes. One day, her friend Castell helped her, and it only took 6.67 minutes, so like 6 2/3 of a minute, roughly. How long would it take Castell to do it alone? So we write Huang, we write Castell, we write together. What's the speed of Huang? One whole car in 10 minutes. One car every 10 minutes. Castell's speed, we don't know. Combined speed, 1 over 6.67. We want to get x, so remember that it's 1/10 plus x equals their combined speed. And so x is 1 over 6.67, take away 1/10. We're going to get a big old rational number again, which I like. So we get this beauty, which is 333 over 6,670, and we flip it. And then we decimalize it and find it to the nearest hundredth. So it would take Castell, and I apologize if that's not the real way to say that name, 20.03 minutes. Is it correct though? Yes, it is. Why am I checking each of them individually, like one by one? Well, you know, every now and again, when you find a problem that's a bit of a, I don't know how to do that, then you get paranoid and you really, really want to make sure that you're doing it right. You know? Okay. Working together, Kim and Jennifer can install a new deck in 6.28 hours. So, straight away, I'm putting 1 over 6.28 here. Had she done it alone, Jennifer would have taken 13.7 hours. So I'm going to write Jennifer, and I'm going to say 1 over 13.7. That's her speed. Kim's speed, I do not know that. So I just write X. How long would it take Kim to do it alone? So it's much the same as before. 1 over 13.7 plus x equals 1 over 6.28. So x equals 1 over 6.28. Take away 1 over 13.7. And then we do the reciprocal of that. And then we'll get Kim's speed. And then we're finished. To the nearest hundredth, that would be 11.60. That's how long it would take Kim. 11.60 watt hours for installing a deck. And this one is like really absurd because installing a deck is a multi-part process. It's really not like painting a fence where you can both start at opposite ends and meet in the middle, right? It's a multi-part process. So this is really not an appropriate situation to apply it in. But that's done. So what next? What next is distance, rate, and time word problems. Okay, so a container ship left the Dania Pier. Am I even saying the word pier right? Let's check. Yeah, okay. So, what's it called? Oh, a homophone. That's what it is. When they sound the same, right? Okay, so peer, P-E-E-R, that's like colleagues or whatever. And then peer, P-I-E-R, that's something that's sticking out at a beach from the sand into the sea. And it's often with amusements like arcades and mini golf, and maybe they sell hot dogs and chips and so on. Right, fine. So, a container ship left the Dania Pier and traveled north. An aircraft carrier left 4 hours later, traveling at 30 miles per hour in an effort to catch up to the container ship. After traveling for 8 hours, the aircraft carrier finally caught up. What was the container ship's average speed? Okay, so what's the picture? Wait, just gonna have some water. Okay, so the aircraft carrier left 4 hours later and traveled at 30 miles an hour after traveling for 8 hours. So how far has the aircraft carrier gone? You know what? Just for a change, I'm going to write in blue. So 30 miles per an aircraft carrier. Oh, right. Okay, that actually does make sense because it's a water vessel and it's 30 miles per hour. Fine. 30 miles per hour times 8 hours. And what do we get? Well, we get 240 miles. And when we have the unit for miles by itself, Please don't write M because that looks like meters. Write MI. Great, because that looks like miles. So that's that much we know. It traveled 240 miles. And wait, is this good enough information? Oh, of course it does. What am I talking about? Okay, so oh gosh. Okay, I guess a little bit of fatigue is setting in, but we're going to push forward. So, come on, think, push. So, the container ship must be going less than 30 miles per hour, of course. Okay, so if the container ship is going at like 20 miles per hour on average, yeah, and the aircraft carrier is going 30 miles per hour on average, you can think of the aircraft carrier as like making its way towards a stationary container ship at a speed of 10 miles per hour, because that's 30 take away 20. Okay, so in this case, though, what's the story? The story is that the container ship has been out at the sea, traveling for a solid 12 hours. That's what's going on. So imagine you're on the container ship. You left at lunchtime, noon, and then it's midnight. And that's how long you've been on the sea for. And as for the aircraft carrier, you left at 4 p.m. and then you catch up to the container ship at midnight. Okay, so what was the container ship's average speed? Well, the container ship has, been going that entire distance, that 240 miles that the aircraft carrier had to traverse across, but it's been going across there in 12 hours. So that gives us 20 miles per hour for the average speed. I do apologize for how slow I'm appearing right now, but I guess I'm not so used to just continuous a barrage of questions, but you must develop an endurance. All right. So, problem 2: a cruise ship made a trip to Guam and back. The trip there took 12 hours, and the trip back took 9 hours. It averaged 20 kilometers per hour on the return trip. Find the average speed of the trip there. So, it took 9 hours to get back, and it did so at 20 kilometers per hour. So the trip back was 20 kilometers per hour multiplied by 9 hours, and then we get the overall distance from the point of departure to Guam, which is 180 kilometers. Great. And the trip there took 12 hours. So do 180 kilometers and divide that by 12 hours. Right? And then you get the amount of speed, the amount of kilometers per hour, which is the average speed of the trip there. Okay, so 180 divided by 12 is 15. So 15 kilometers per hour. That's great. Problem 3. Scott left the airport and traveled toward the train station. So airport, train station. 3 hours later, Castle. You know what? I really want to learn how to say that name. Just excuse me while I try and get what that name is. So the way that I'm going to do it is I'm going to open up a website called Forvo. forvo.com. A great resource for pronunciation.
Robert Castel.
Oh, so it's like a French name. Okay, I'm just going to say Castel. Okay. Sorry, Castel, whoever you are. 3 hours later, Castel left traveling at 50 miles per hour in an effort to catch up to Scott. After traveling for 2 hours, Castel finally caught up. So, Castel has traveled 100 miles. And it took Scott 5 hours to travel. Scott has been traveling for 5 hours. The 3 hours delay from Castle and the 2 hours to catch him up. So 100 miles divided by 5 hours is simply 20 miles per hour. That's the average speed of Scott. In problem 4, Jose traveled to the town hall and back. The trip there took 5 hours and the trip back took 4 hours. He averaged 35 kilometers per hour on the return trip. Find the average speed of the trip there. Okay, so for 4 hours, he kept up a speed of around 35 kilometers an hour. So the distance to the town hall is 4 hours multiplied by 35 kilometers an hour, which gives us, what's 4 times 35? That is 140. 140 kilometers. Now, the trip there took him 5 hours. So 140 kilometers in 5 hours. So I write down speed there. Do I just write down speed there? No, I do not, because that's inaccurate. I should write down average speed there. For all you know, he stopped at a gas station and bought himself a sandwich. So I'm going to write AVG with a little tiny dot. That's how you abbreviate the word average. So the average speed there was the distance there divided by the entire time that it took him to go there. So 140 kilometers divided by 5 hours, which is what? 28 kilometers per hour. And that makes sense. because he's clearly slower going there than he is coming back. Okay, problem 5. Perry left school driving toward the lake 1 hour before JD. JD drove in the opposite direction, going 6 miles per hour slower than Perry for 1 hour. You know what? I should be checking these, shouldn't I? Okay, it seems good so far. JD drove in the opposite direction, going 6 miles per hour slower than Perry for 1 hour, after which time they were set 174 miles apart. What was Perry's speed? First note, if you say the word, if you want to abbreviate miles in the middle of a sentence, I guess sometimes you have to put a little dot afterwards. I don't personally do that, but okay. So I'm going to write school. I'm going to write lake. Perry left school driving toward the lake 1 hour before JD. So Perry's out of the gate and he's been traveling for 1 hour. Okay, and then, so Perry's already been traveling for 1 hour and going like that way. And then JD is driving like in the opposite direction, that way. And JD is going 6 miles per hour slower than Perry for 1 hour, after which time they were 174 miles apart. Oh my goodness me. Okay, you know what? I'm going to represent JD's speed like this. Instead of having variables like P and J flying around, like a pair of variables, I don't want that. I'm going to have Perry's speed be P. And JD's speed, I'm going to have it be P minus 6. Okay? P minus 6. And it's going in the opposite direction. So it has to really be the negative of that. You know, but hold on just a sec. So that's JD's speed right there. So the gap between them is closing up. Okay, so first hour. The gap between them closes by this much. It closes by whatever Perry's speed is, right? Let's just say that Perry's speed is 20 miles per hour. After the first hour, the gap between Perry and JD is 20 miles smaller. Okay. So how am I going to say that? Okay, after the first hour, the gap between them is like, look, I'll just say P, okay? Okay. And after the second hour, how much more? Perry's going to contribute his speed, which is P. And JD is going to contribute their speed, which is P minus 6. So like, So after like 2 hours, 3p minus 6. Oh, why am I not getting this? Like instinctively, I want to say that's equal to 174. Add 6 to both sides, so we get 3p equals 180 divided by 6 divided by 3, so we get 60. Right. But that's... Should we just see if that's right? Okay, it actually is. But I have to understand it, right? Okay. So but why is that true? Like, how can I articulate the truth of that? How to articulate this? After 2 hours, Perry clearly travels 2 lots of B. Okay, I'm quite befuddled as to how to actually articulate how I even got that. Right, we're going to do problem 6. And if I can't articulate it, clearly the fatigue has overwhelmed me. So, Wilbur left the hardware store and traveled toward the recycling plant at an average speed of 33 kilometers an hour. So, I write hardware for hardware store. I write recycling for the recycling plants. And Wilbur left the hardware store and traveled toward the recycling plant at an average speed of 33 kilometers an hour. Okay. He's going that way. Mary left 2 hours later and traveled in the same direction, but with an average speed of 55 kilometers an hour. How long did Wilbur travel before Mary caught up? Okay, that's fine. So, first of all, if Mary left 2 hours later, Wilbur has already covered 66 kilometers. So the gap between them is 66 kilometers. And, Wilbur's going at 33 and Mary is zooming up behind him at 55. So it's as if Wilbur is standing still and Mary is just coming up behind him at 22 kilometers per hour. That's how I think about it. Right? Like the difference in their speeds. So Mary's catch-up rate, that's a good way to say it, is 22 kilometers an hour. And so 66 kilometers divided by 22 kilometers an hour gives us 3 hours. And that's how long Wilbur has got to travel before Mary catches him, I believe. Oh no. Look at that. It's wrong. 5 hours? Oh, wait. Oh, wait. Do you see where I got it wrong? Of course. Mary left 2 hours later. And it's saying how long did Wilbur travel, not how long did Mary travel. So add that on and you get 5 hours. Okay, no problem. But like I say, I mean, you got to be honest. I didn't get that one accurate. Maybe I would have done if I'd have looked at it with fresher eyes. But I appear to have reached the limit of my stamina. So I'm going to go for a walk before I do any more. You have to take breaks. Okay, that's all fine. I'm going to end it here.